So the following is just a short demonstration of MATLAB for those of you who took the Freshman Studio last year. Or there's a few of you in the class who are taking the class out of sequence and maybe haven't had any MATLAB. But when you open the MATLAB program, which you can get on any of the lab computers or from the Apps Anywhere that they're using this year. But anyway, you'll open it up, and depending on how the software was installed, you might get a slightly different configuration in terms of how the different windows are. One of the first things that you want to do is check your working directory folder. It'll usually default to some MATLAB folder under your documents. But especially if you're working in the lab computers, you're going to want to change that to your own directory. I'm going to put it in my geomatics folder. But once you change the working directory, you'll see lots of all the files that are in there, not just MATLAB files. But when you run your code, you need to be in the same directory as where the code is stored. So once you have this, you'll see, anyway, you have your directory on the left. This is the editor window. This is where you're actually going to be writing the code. You have a command window down here, which is where you're going to be running the code. And this is where your errors are going to show up if you have some coding problems. And then over here is the workspace. And this is where when you define variables and it's storing variables throughout the program, you're going to see them sort of pop up here. Up above, you have different tabs and icons and ribbons and whatnot. In general, you're probably going to be working on either the Home tab, which is where you can change the layout. So if you accidentally close one of these work areas and you want to bring it back, you can click these on and off. I usually just hit the default when things kind of get wonky, and it brings me back to this view. And if I'm in the editor, you'll see, that window, you'll see some additional menus come up. And so as you're writing your code, you're going to be running it from here. You can also, comment out things and put breakpoints. But this is the main thing here. This is where you're going to save your .m file, which is the file format for MATLAB. Okay, so I can go ahead and save. It's going to, MATLAB code files are what are called .m files. So we're going to be using a differential leveling example from in-class problem 2. So I'm going to save it as leveling EX. I have multiple code files open, but it'll just create a new tab for that. And just as a refresher, remembering in class problem number 2 where we were talking about differential leveling, we're going to write a computer code that's going to do the leveling calculations that we did in this problem 3. And so it was a leveling circuit with 3 turning points and 2 benchmarks, and this was the solution. So if I was given a series of backsites and foresights in this problem, so I went ahead and put that into a .txt file. You could type this in Excel and do a save as to get your .txt. You could leave it in Excel, but the example I'm going to be doing is everything is going to be based on a text file. Anyway, I get my backsites and my foresights for each essentially instrument setup. So the 7.485 and the 2.641 is from this instrument setup. So the backsight and the foresight, we move the instrument, backsight, foresight. Right. So going into the MATLAB, so I'm going to be typing my code in the editor version, or the editor window. So in MATLAB, if I put a % in the front, it is a comment. So this is code that wouldn't be executed, so it tells the program to ignore this. So I always start off with a comment that tells me what this particular code is going to do. This is a program to determine elevations of points on a level circuit. And the first thing I need to do is start defining variables and importing those variables in. So I'm going to create a variable. It's going to be a table that is called readings. So I'm going to use so I set, this is my variable name, readings, right? And then I'm going to set it equal to, and this read table is a function, right? And now I'll say where my code exists. So within apostrophes, that's the name of the file that I'm going to read. Right? And so I have a file over in my the one that I just showed you, that text file in Notepad, right, is level_matlab.txt. So I tend to write my code a few lines at a time, and then I go ahead and run it. So if I'm in this editor tab, I see a run function, so I can hit run. And a couple things are going to happen, right? So this read table, it's going to read a 5x2 table. It's called readings. And it also is going to put it down here in the command level, right? So I can see my backside, my foresight. So a couple things about MatLab that's can be different than other programs is it's very much case sensitive. So my variables, so if I were to change this to a little r, I'm going to run this again. It's actually now created two different variables, right? If I want to know more information about any of these variables over in the workspace, I can double click it and it kind of brings it up in a spreadsheet view. So I see it's a 5x2 table. So MATLAB always talks about the number of rows is the first one and the number of columns. So that's why it's a 5x2 as opposed to a 2x5. But I see readings. And anyway, so if I were to, in later parts of my code, refer to it with a small r, right, it would be a different variable than the large R. So I actually only want one of those. So I could go in here and delete it this way. I can also go down in my command window and type in the word clear. This will clear my entire workspace. If I type CLC, it will clear my commands. Another way of getting to that same thing is clearing commands or clearing workspace up here from the home menu. So sometimes when you get a lot of errors when you're working through your code, you sometimes want to just clear out the commands so you can sort of start fresh. Another thing about MATLAB is sort of suppressing output. So if I don't want to see it down here in the command window, if I put a semicolon at the end, when I go back to editor and run it, it executes that line of code. It creates that variable, but I don't see it down here. So I'm not kind of cluttering my command window, and I'm not taking, you know, for large files, sometimes it takes a long time to display all that, and it can really slow your program down. So, okay. Now I want to create some variables that I'm going to use in my program. So the first thing I want to do is I'm going to set a command that tells me how many rows that I have. I'm going to create a program that's going to solve this particular problem that we did in class 2, but I want it to be flexible enough that it can solve a level circuit of whatever length it happens to be. So if I use the length command, right, I can it will return a scalar number, a value for how long, and I'm going to use my readings.bs. So a couple of things here. So this length command is another function within MATLAB similar to read table. If I were to capitalize it, length like this, it actually wouldn't recognize it. We're going to run it both ways so that you can see this. But the commands or the functions, defined functions within MATLAB are all in small case. So if I go up here, I can type in that length, right, and I can get information about what that does. So L equals length. I could set, you know, it to any variable. It could be X equals length, right, and it's going to return the length of that variable. So the help function in MATLAB is really good, and it's gives you additional capabilities. Sometimes there's some additional functions within a defined function that you want to know more information about, and I'll show you when we do some later lines of code. So the last part of it is I'm telling it it's a variable. Because I brought this in as a table, So a table says that it's going to keep the backsite and foresights together. If I were to sort the table by backsite, maybe by magnitude of backsite, it would always keep the matched pair of foresight together. That's different than if you were to bring in each one of these as its independent array, column array. So whenever you want to call variables in a table, you always have to start with the table name and then dot, and then this is whatever variable. So I could have used .fs, and it would have told me how many rows there are or how long the foresight column was. These are matched pairs, so both of these are going to return the same number. So I'm going to hit run, and you can see that it creates a variable L that has 5, so I have 5 rows. Just to sort of show what happens if you're, how case sensitive these are, I can run that, and it's actually going to say undefined function length, so it doesn't recognize that that is a defined function, so it needs to be in the lowercase. So remembering how we solved this problem, we've done a lot of differential level problems in this class, so this should be pretty familiar. But we have an initial elevation, right, and then we add the backsite to get the height of the instrument. We subtract the foresight to get the new elevation. So that's what we want our code to execute. So we know we're going to need the height of the instrument. So I'm going to define a variable capital H and capital I. I'm actually going to allocate the array, and I'll talk a little bit about this in a second, but I want to show you some of the conventions of it. So what this does is it finds space, and it says I'm going to create an empty array or array full of zeros. So the zeros is another function within MATLAB, and I want that array to be remember it does rows, comma, columns, so I want it to be an empty array of zeros that is L long, so in this case 5 long by 1. So I'll put that there. You can put comments in the same line as codes. As soon as it sees the % sign, it's going to ignore what is it. I'm going to say I'm an array for height of instrument. So this is something that you do for calculation efficiency. If you're running lots of code with lots of rows, it's faster for the program to run if you kind of pre-allocate the array. For what you're doing in this class, it's not important, but I think it's good programming to do. Zeros. So I'm also going to do the same thing for my elevation array. So I'm going to say array for elevations. So I put the semicolon. It's not going to show me those, but when I run them, you can see that it created. So the way it shows over here, if it's a small enough array, if it's too big, it just will tell you the dimensions of it. But if it's small enough, it will actually show you the values. And when it shows an array that's actually a column array, so it's in a single column, instead of using commas, it's going to put semicolons. So that tells me it's a column array full of zeros, and the height of the instrument also is a column array full of zeros. So the first thing that we need to do, kind of back to this calculation, is we always have to start with an initial elevation. Well, this data wasn't in the original. All I had in the readings were my backsights and my foresights, so I need to set that. Since that's a value that could change, I want this program to work with multiple text files. It's information I'm going to have to get from the person running the program. So I'm going to set a variable called initial elevation. This is good programming convention is to use what they call camel case, where you set the first letter of kind of each word in capitals and the rest are smaller. That's something it isn't required by MATLAB, but is good sort of programming. So I'm going to use the input function. So this is something where we ask the user to input. I'm going to tell the user what I'm looking for, so what's called the prompt. So elevation. So I put these in apostrophes. So similar to how I had the file name in apostrophes, this is the prompt that's going to be shown on the screen, asking the user to put in the initial elevation in. So when I run this, you'll see down here on the command line, it ran through all those, it says what is your initial elevation, and it actually won't run any code past this point until it sees that. So our initial elevation is 48.292 meters. So when I hit that, right, it finished the code, I get back to the command prompt, but you can see over here I have this initial elevation of 2920. So kind of looking at this, we're trying to, we're going to have an array where we do the height of the instrument, and we're going to have an array where we do the elevations. But the first elevation in that array is going to be the initial elevation. So in our code, we want to go ahead and set the first elevation. So we're going to use some indexing. So we're going to say in elevation, and we want it to be right here. We want to put that value there. So we're going to say elevation in column 1, row 1. We're going to set that equal to the initial elevation. I'm using semicolons because I don't need it to show up down here. And so when I run this, it's going to rerun the whole code. It's going to ask again for the 48, the initial elevation. And we'll see it executed the code and it put that 49.292 in the first column. I can look at it this way. So the first column of the first row. So that indexing of tables of two-dimensional arrays is done with the comma. First the column, then the row. Now I have a series of backsites and foresights, right? And if I see this, right, I'm going to have to add the backsites. So the elevation, I'm going to add the backsites to get the height of the elevation, or height of the instrument. Then I'm going to take the height of the instrument minus the foresight, right? And I want to do that multiple times. In this case, I'm going to do it 5 times, but I want my program to not be limited to just this particular set of data. So how we do that is with a for loop. So for loop, we're going to use an indexing variable. I tend to use J and I, so I'm just going to go ahead and set it to J, but that could be anything. It doesn't have to be a single letter. It could be, I could set it equal to loop instead of J, but I'm going to want to run it. I'm going to start where my J is equal to 1 at the beginning, and at the last iteration it's going to be equal to 5, right? So that's why this would work for any amount of data. If I had 500, it would set length equal to 500. It would see that in the original data that I uploaded, and then it would run the loop 500 times. So I'm going to put this in there, create a for loop that will run through each row of data. So now it's asking me what, this begins the loop, it sets the number of times the loops would go, and now I want to create the actual calculations. So my height of my instrument, right, so this is going to populate this, right, so I've got these 5 zeros. So the first one, I'm going to use my indexing variable J, because at the beginning it's equal to 1, and then it's going to loop through 1. The second time it's going to go to 2, and so on till 5. So each time this number is going to change. So the first one, it's J1. So my first iteration, it's going to put in column 1, row 1. I need to add my elevation, my initial elevation. I could, if I set this to initial elevation as opposed to elevation, it would always pull the 48.292. But every time I go through the loop, I needed to add the previous elevation. So, right. So by indexing it to this array as opposed to this value that doesn't change, every time I loop through, I have a new elevation that I'm going to be performing the calculations on. So I need to add the backsite, and so that's in table readings, and it's the column or the variable column named backsite. And so I'm going to start with 1 for the first one, but I'm going to index it to my J. Okay. And then the next thing I need to do, right, is I take, to get my elevation, okay, so let's go back to this. So I have this in here. I've added my backsite to here, and now I need to take my height of my instrument and add the foresight, right, to get the new elevation. So my elevation has to start. So it's my elevation of my next point. So this is, right, if I just said my elevation of J, my J is 1, it would want to put it right here, right? But that's my initial. So I need to index at whatever my J is, I need to do +1. So the next elevation, it's going to go column J +1. Sorry, I had extra there. So that tells it the column is J +1 and the row is 1. Or wait, the row is J +1 and the column is 1. Sorry. Of my elevation, I'm going to add my height of my instrument. So the first one, and now I'm going to subtract off my foresight. And so it's going to, like I said, within this, once I start the for command, right, it's going to execute whatever amount of lines of code I have until I type in end, right? And it's automatically going to do this colors. It's going to see the beginning of the for and the end. If I had nested loops, if I did add a for loop and then I did another for loop that was running through a subset of the code, it creates these like brackets to tell you all the, that this end goes with this for loop, so you can easily see what code is being done within the loop. So let's go ahead and run this. It's going to ask my initial elevation every time. Okay, so I'd like to say I designed that, but I was just too busy talking. So once I ran that code, I got an undefined variable reading in or class reading FS, and then it tells me the error down here. So what's happening here in this reading is I forgot the S, so it tried to think it was a new variable. The other piece to it is this is readings. I always have to, when I'm working with tables, have a column and a row. So I need to put that (1). Right? So then if I run this, ask my initial elevation, then we're going to see that it populated all the elevations, right? So let me bring this up and have it be a little shorter so you can see. So if I look at my head of my instrument, my first one is 55.777. I get the 57.118 and so on. So I see my 5 heights of my instruments because it ran through. The other thing that we can look at when we look at the elevations, which is this top one, right? I have my initial elevation, then I see the 53.136, the 48.475. So it's matching up with these, right? And it's getting all the way to the end, the 48.276. So it's calculating it right, but I do want to make the point, when we first defined this, we said that we were going to set the elevations equal to L, 1. So it set it to a 5 by 1 matrix. And then when it ran through all this, you'll actually see that it created 6, right? Because of that J + 1, we had the initial and then we had the 5 rows of calculations. So even though we pre-allocated it with zeros for the length, the for loop can expand these arrays on the fly. So which is nice because sometimes, through the calculations, you don't exactly know how many iterations. It's still good practice to kind of define them and pre-populate them, but you do have flexibility for how large your array is at the end of the calculation. So the next thing that I want to do is to talk about some of the output. So I could go ahead and have it display the table of the elevations and the height of the instruments, but what I want to do for this is to make sure that you remember some of the plotting functions, because for your homework you're going to you ultimately want to know what the final area is of your polygon, but also you're going to have to display what that polygon looks like, right? Using the coordinates for it. So in this case, I only want to plot the elevations. So I'm going to use the plot command. I'm going to plot the variable elevations. So this plots a single variable. This is one I want to show you how good the help function is. So if I typed plot in, it's going to tell me. So you're actually, for your homework, you need to plot an x and a y, but this tells you, what variable, by the first variable, comma, the second variable, whatever you put in the first is going to be your x, whatever you put in the second is going to be your y. And there's a lot of qualifiers that you can put in, but anyway, through this help, if you want to make dash lines or different color lines or change your tick marks, all that is going to be in that help function. We're going to let everything kind of default here, but I do want to put the X label. So this is text that it's going to put on your x-axis. So we're going to say that our x is just a point. Because we just have elevations. In this case, we don't have distances. It wasn't part of our original input file, so this is just saying which point or instrument setup or whatever you want. But at each turning point or benchmark, this is the elevation. And so our y label is going to be elevation. I could put in meters. I think that's what this one was for. But if I go ahead and run this, going to ask what my initial elevation is, and you can see it has elevation and my calculated elevation and my different points. There's some different formatting. I can do some things in here where I can insert legends and titles and make it look a particular way. If I do it within this figure one, it's not going to be part of the code, and anytime I create new output, I'd have to go in and rework this. But if you're making just a single figure, it can be nice just to do some of the formatting directly in here. Okay, so I'm just going to clear those commands. I want to hit save to make sure I save it. And then if I wanted to read a different data set, I would just have to go back and change just what table it read, and I could change it to whatever text file I want, and it would run through, and it wouldn't be limited to just 5 rows of data. So hopefully this was enough to kind of dredge back some of those MATLAB memories, and you're not going to necessarily use everything for your homework, particularly this user input. That's not something I think your data set is, when you set it up, will contain everything that you need. You don't have anything that you need to do that, but you're going to have some sort of for loop, and you're going to have a plotting function. And you may have some additional calculations that happen either before or after your looped ones. So you may want to treat initial calculation or a final calculation a little bit different than you do all the ones in between. So that might be something to think about. You do not have to have everything in the loop. So hope that helps. Good luck.